from an idealist perspective, quantum mechanics and the way that it works is exactly what you would expect if matter does not have objective presence over time.
Keep watching to learn more.
Book 4 in the new Thinking Aloud dialogue series is Charles T. Tart, 70 Years of Exploring Consciousness and Parapsychology, now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today, we'll be exploring the question of whether consciousness causes the collapse of the quantum wave function. My guest is Richard Lucido, a school psychologist living in the Detroit, Michigan area. He is author of Existence and Consciousness, a theory of naturalistic idealism. And he has also designed an ingenious experiment to test the proposition that consciousness, in fact, does cause the collapse of the quantum wave function. Well, I know that sentence raises more questions than it answers, and we'll be exploring those questions now. As I mentioned, Richard lives in Michigan, and now I'll switch over to the internet video. Welcome, Richard. It is a pleasure to be with you today.
Thank you very much for having me.
You've been a psychologist and a philosopher looking at the question of consciousness, and you've come around to the idealistic point of view, which frankly is one that I lean towards. I can't say that I'm 100% convinced, but I think there are many good reasons to take it very, very seriously. And viewers on New Thinking Aloud will be familiar with idealism because we've done over a dozen interviews with Bernardo Kastrup, who is one of the foremost writers and thinkers advocating for idealistic metaphysics. But it's probably the case that many of our viewers will not have even discovered those videos yet. So let's begin with your definition of idealism.
Idealism is the idea that the primary constituent of reality is consciousness, that it's not physical, like physicalism. Physicalism would say that the primary constituent of reality is physical things, atoms, molecules, space, and time. Idealism is the complete opposite. The primary constituent of reality is non-physical things, consciousness, spirit, mental things.
And that point of view would seem obvious to many philosophers, even philosophers who are not idealists, because they recognize that philosophy does begin, as Descartes put it, with our own internal awareness.
Absolutely. Descartes was a great philosopher who separated mind from matter. The way that he thought about it, he really, with that day where he lied in bed 500 years ago, and he thought about the things that he can prove and the things that he could disprove. And he knew that he could disprove, or he couldn't be 100% sure of the things around him because his senses have deceived him in the past. He couldn't be 100% sure about even facts that he knew, like 2 + 2 = 4, because he's made mistakes before, as we all do. And then he finally asserts that he can't even be 100% positive about his own body, because he had dreams before where he didn't have an arm or he didn't have a leg, where his own body even wasn't there, only to wake up find his body was, perfectly intact. So you can't even trust your own physical body existing. But the one thing he thought that he could not doubt was that he was conscious, because he was having these thoughts about numbers, about the outside world, about his own body.
In other words, I think, therefore I am.
Yes. That's where it comes from. And that's a great separation.
So subsequently, philosophers have more or less come to agree that we cannot prove absolutely, as in a logical or mathematical proof, that the external world through which we navigate our daily lives every day and take for granted really exists.
Yes, they've tried. Bertrand Russell, one of my favorite philosophers, I'm paraphrasing here, but I think he says that it's a sham. It's a shame that if somebody says the world doesn't exist, that we can't give them an airtight proof. But none exists. It's been a theme in philosophy for the last 400 years. Idealism actually goes back to Indian texts. It's thousands of years old, but the last 400 years since Descartes, with Bishop Berkeley and others, have really tried to move the ball forward on that idea.
Of course, most people would say common sense alone will tell you that the external reality is real because it's there every morning when we open our eyes.
It's not something that's completely obvious. You have to think about it a little bit. You have to think about it's there every time we open our eyes, but we only experience it through what happens behind our eyes. We only experience it through our consciousness. We're inferring that it exists through the consciousness, which is the only thing that we have direct access to. So I'm looking right now at my refrigerator, at this very second across the room. And the only way I know that my refrigerator is there is because I have consciousness of it. If I didn't have consciousness of the refrigerator, then there would be, in my mind, there's no way to prove that, because consciousness always has to come first. It's behind things. It's so far behind things, it's almost hard to talk about it.
Well, I think it's fair to say that many great scientists have come to that conclusion. Max Planck, the founder of quantum physics, said it very explicitly, that consciousness is fundamental. You cannot get underneath or behind consciousness.
Absolutely.
But now, bringing up quantum physics, we have a whole theory of matter going down to the tiniest particles that seems to have been well confirmed in, must be thousands and thousands of experiments by this time.
Yes, quantum mechanics is the bedrock of physical science. Its predictions are perfect, more perfect than anything else that has ever existed. And from the idealist point of view, coming across quantum mechanics, it's almost perfectly as you would expect from an idealistic point of view. So I don't think that when people are trying to put consciousness and quantum mechanics together, that some people, physicalists, might say that consciousness is being driven into quantum mechanics. I would have the opposite direction. If from an idealist perspective, quantum mechanics and the way that it works is exactly what you would expect if matter does not have objective presence over time.
I mean, a lot of people put it very simply, which is if you understand the physical world as described in theoretical physics, it's mostly all pure vacuum, that the particles exist very far apart from each other, actually.
Yes, it's empty. It's mathematics. The physicist Max Tegmark, a physicalist, is really driving home the idea that individual particles exist as their definition. They exist as their mathematical ideal. The reality, physical reality, is mathematics. And that's gaining some steam in physics. It's not the mainstream point of view, although I don't know if I could, discern that. But Archibald Wheeler.
John Archibald Wheeler.
Yes, it from bit. So when I hear that, I'm like, okay, well, that's perfectly. Matter appears to be information. Now we start from the same point, Wheeler and Tegmark, as I do, with matter seems to be information, but we go in very different directions from that. From an idealistic point of view, I'm like, well, that's perfect because information is made for consciousness. And they go in a different direction with it. But I think that's what you would expect if you are an idealist when you come across quantum mechanics.
Well, what does it mean to say that matter is derived from information?
This is the way that I see it. I think of, and I want to take a step back and just get a little philosophical for a second. I want to talk about Jean-Paul Sartre, which was a great existentialist philosopher from the 20th century. And he breaks down reality into being for itself and being in itself. And I kind of think in the same way. My philosophy does not map completely onto Sartre's, but it's very close. So I have to absolutely give him credit for, putting this germ into my thinking and this motivation to kind of like think about being first. And what I'm talking about is the idea that existence precedes essence. So existing with something, the life that's in something, and essence is kind of like its description. So in some cases, there are beings that consist only as their essence. A good example of this would be a number. So if I had the number 3, I could think of the number 3 exists as its essence and only as its essence. It exists as its defining information. It can't become damaged. It can't grow. It can't change in time because it has no being over time. Number 3 is its definition. It's 2 plus 1. It's 5 minus 3. It's the square root of 9. It's frozen in time. And what physics kind of, is telling us, even though the physicists they don't adhere to this, but the fact of what you keep hearing is that all the elementary particles in the standard model, they exist as 3 separate measurements: spin and weight. And if we know those measurements, there's nothing else beyond those measurements that exist. They're described completely by those measurements. Now, you could say, well, those are just the building blocks. But this is where I think the rub is. This is where it gets you have to be really, really careful. When I think of building blocks, if I think of like the bricks that are used to make my house, I can hold a brick in my hand and I can look at it and I can see that they're totally distinguishable from another brick. I can have 2 bricks in my hand. I can be like, all right, well, this is the brick in my right hand because I can see little differences. I can see little differences in this brick. So these bricks have existence beyond their essence. They exist differently than the definition of brick. But numbers and elementary particles are not indistinguishable. I mean, they're not distinguishable. They're absolutely indistinguishable. They exist only as their essence. So I have a 3 here and I have a 3 here, and then I got 23s in the back of my truck. They all exist exactly as number 3s. There is no analogy with physical things that we can touch in our hand that compares to how deep that is. And why that means so much is if you have things that exist only as their essence, they're frozen in time. They don't have existence over time. They don't have any being over time because all they exist as is information.
And how about space? I would presume they don't exist in space either.
My type of idealism, what I would think of is that space is part of the physical system, which would also just be information. Because space has nothing that escapes its essence. For Sartre, and for me too, the being that escapes its essence, that can leave its definition, that exists beyond it, would be consciousness. Consciousness can't be its essence. It always exists beyond it. And I can go in and I can explain a little bit more, about how that is.
Do that, please.
Oh, so if you think about it, and every moment of consciousness, it has a floor of time which you can't get underneath. For example, there's things that a photon can do and an electron can do in a billionth of a second, in a millionth of a second. But I can't experience anything. I can't have like a red experience or a sound of a C-sharp minor experience or the feeling of cold that lasts in a millionth of a second or even a thousandth of a second. There's a floor in time where 2 things, if I saw them, would appear to be occurring simultaneous. Now, for different modes of perception, this is different amounts of time. And so science, about 70 years ago in the 50s, they would do experiments where they would show 2 flashes of light And if they put the difference between the two flashes of light close enough in time, the person looking at them would be like, well, those two flashes of light occurred simultaneously, because in their consciousness, they occurred during one period of time, which you could call like a temporal extension of consciousness. One chunk where in about 50 milliseconds, maybe for certain modes of perception, it's up to 100 milliseconds. And neuroscientists have been thinking about this. Beyond consciousness, beyond philosophy, neuroscientists are debating whether or not consciousness is discrete or continuous. But it seems like on some level it has to be discrete, meaning it's one block of time. Now, this is how consciousness, in my view, would escape its essence. Because in this block of time, this 50 millisecond-ish block of time, all the points have to exist as co-occurring equals, because it's not separated in time. So if I have the scene of this red experience, I could correlate it with the neurobiological happenings in my brain at time frame number 1, time frame number 2, time frame number 3, 4, 5, 6. There's actually an infinite number, or near infinite number of time frames where things are happening inside your brain between 1 millisecond and 50 milliseconds. So you would ask yourself, what frame correlates with your conscious experience of seeing the red? It would have to be all of them, because it can't just be the first one, the second one, the third one. If it exists during the whole time, it's going to have to be finished. All those snapshots, in my mind, would have to be finished to complete the correlation of my seeing of red with the information, the things that are going on in my brain for seeing the red, because consciousness, unlike anything physical, holds on to a definite span of time, every moment of it. This is why it escapes its essence. This is the big point. While it's living during that 50 millisecond span of time, it can't, in principle, be matched up with its essence, because it hasn't ended yet. Once it's ended, once consciousness is ended, once that 50 millisecond span of time is ended, then I'm not experiencing it anymore. Then I'm on to the next thing. I could be doing another 50 milliseconds of red, of course, but that 50 milliseconds of red experience that's in the past, that's gone. And from existential philosophy and from my thinking, all right, well, that's in the past again, so now that exists as information. But what I'm talking about is live consciousness. What's happening in that moment can't, in principle, be reduced to its essence. And that's how I would, address that problem of how do we explain consciousness from physical things. That's why the hard problem is so hard, because you can't have the correlation because of the way that consciousness exists differently in time. Because unlike the number threes, every moment of consciousness holds on to its unique and distinguishable existence over time.
Well, for example, this video, I presume when people are watching our conversation over, let's say, over the internet, they're watching a video in which the frames change approximately 30 times every second. Now, 50 milliseconds would be 20th of a second. So at that rate, one could maybe barely see the flickering of the frames, but at 30 frames a second, it appears like continuous motion to people. So that's sort of what you're getting at. I know when I was an undergraduate in college, we used a device called a tachistoscope to measure what was then called the critical fusion frequency. They would flash a light, you would be looking at it like through a microscope, and the light could be of different brightness, different colors. They could vary the light in different ways, but they would flash it, and they would ask, at what point does it seem like it's no longer flashing, like it's a constant light? And that would be the critical fusion frequency, and they had very regular mathematical curves in terms of the brighter the light gets, the faster the critical fusion frequency needs to be, for example.
Okay, fantastic, because the waves are closer together, is that?
Well, I don't know exactly the theory behind it, to be honest. I do know that they had Fechner's law and Weber's law. This is basic psychophysics, the relationship between human consciousness and the physical world. And the critical fusion frequency was a key indicator.
From my thought, exactly where that is, and because different levels of perception, I think that would be different. So like you can see something and have an experience of that, like faster than you can feel cold, or things that are more complicated, like jealousy or rage or love. I can see a flicker in a smaller amount of time. So exactly, what it is for different, is it overlaid? Is it not? Neuroscience is working this out. And, we get new information all the time. For my money, for, the way I see idealism, as long as it's not in zero, as long as it has some extension in time, which it obviously does, because physical things, it's an infinitesimal, amount of time, as a photon is traveling. Consciousness does not exist in an infinitesimally small amount. There's a length to it. And 50 milliseconds, like the TV rate, seems to be a good jumping off point.
I've had discussions with the physicist Bernard Carr, who has theories about the nature of time and multi-dimensions of time. But one of his speculations I thought was fascinating is that whereas for a human being, a unit of time is roughly, as you say, 50 milliseconds, it could be that there are other conscious beings, and for them, a single unit of time might be what would be a year for us, or a whole day, or a month, or even a million years.
That's a fascinating thing. I've toyed around with thinking about that myself, and like how, or even if you could change a human beings with practice in some way to make it bigger or to make it smaller. I don't think you can make it smaller, but I don't know. But it is a fascinating idea, because I think that if it was longer relative to how much stuff's going on in the brain, I think that, it might be advantageous in some way, or things would be different. Things would definitely be different. Evolutionary wise, like you're interacting with our environment, if it's too long, well, then we're too slow. So there's pressure, to keep it short so we can react to other animals, things that are, occurring in the environment.
Suppose an entire galaxy was a conscious being, like the Milky Way galaxy is over 100,000 light years from one end to the other. So if a galaxy were a conscious entity, it would almost necessarily have to have a longer unit of consciousness time-wise.
Yes, absolutely. It would, because it's just that it's that much bigger. If electricity and photons and exopitosis are going through our head and it's 6 inches wide, something the bigger would obviously need more time. Yeah, I don't think there's anything special about it that 50, it's special for us, the 50 milliseconds, but special for consciousness overall, I don't know.
Let's talk about the quantum wave function. We introduced this video by saying we're going to examine the question of whether consciousness causes the collapse of the quantum wave function. I'm pretty sure that a large segment of our audience won't know what we even mean by such a thing as a quantum wave function.
So quantum mechanics was developed in the early 20th century. And before that time, everyone kind of thought that matter, or most physicists thought that matter was continuous, that it could be broken down into smaller and smaller bits. Energy was continuous, where it could just be broken down into super small units of time that never end. You could just keep always infinitely dividing it. But Max Planck discovered that there's a floor with energy. It moves in packets. So quantum means it means discrete entities. And when we look at these discrete entities, if we're looking at, let's say, a photon going on an electric plate, the predictions for any given thing, for any given event, are given by a probability curve, which is the wave function. And we can't tell exactly what outcome will happen within that curve, but we could tell with absolute accuracy that curve is going to predict the outcomes over time. So if we ran that photon, we can't tell exactly what part of the photographic plate it's going to get stuck on. But we know the curve. So if we run it 100 times, 1,000 times, we know exactly where it's going to hit the most and where it's going to hit the least, and how that works, which is nonsensical in a way to the way before you learn about quantum mechanics, how reality works, because you would think that, everything has directly causation from one thing to the next. But that's not the way the quantum physics works. Everything is distributed as far as probabilities. And every time something happens, every time we take a measurement, those probabilities collapse. That's where we get the word collapse, into just one outcome. So from the probability, the wave function, which is a probability wave, we get one outcome every time we measure. Now, what collapses the wave function? What makes that happen? Well, that's the million-dollar question. That's why there's so many different interpretations of quantum mechanics. In the standard interpretation, the Copenhagen interpretation, it's silent on why it collapses, but they just say that measurement causes the wave function to collapse, and that's it. And then we just, calculate and don't think too much about what's going on behind it. There's other interpretations. Everett's interpretation, popularized by many universes, says that the wave function never collapses. Everything actually exists. It never goes down to any specific thing. But what happens is the universe splits into separate universes, and everything happens. It just doesn't happen in this universe, which is, an extreme example, but it works. It works perfectly with the mathematics. You just have to think about it differently as far as what's happening. And there's multiple interpretations of quantum mechanics. The one that I'm most enamored with was from John von Neumann, and later elaborated on by Eugene Wigner, which says, well, it's not the measurement device, the Geiger counter or the instrument that we're using to measure the quantum phenomena that causes the wave function to collapse. It's when that information enters our consciousness. So that's been since called the consciousness causes collapse. So it's not the measurement device that causes those possibilities to get to just one possibility. It's the interaction with consciousness.
And that is a hypothesis that you endeavored to test experimentally.
Yes, I've been searching for years to try to find a way to split that apart, to be able to separate consciousness from measurement. Because it's very tricky when you think about it, because you can't tell that something happens until you look at it. And you can have a machine measuring, a measurement device, a Geiger counter, or another instrument measuring. But what von Neumann said in Wigner is that, well, the measurement device could also be in superposition of two possible states. It could also be part of the wave function. So it's only collapses to one when consciousness interacts with it. And a couple years ago, in 2023, I ran an experiment that tried to get at that, to separate consciousness from measurement. What we did is I was looking at subliminal priming, which is this whole other thing in psychology that's been around for decades. And what subliminal priming is if you see something in a very, very short amount of time, you don't recognize that you see it, but it influences your ability to respond to a different stimulus. So, for example, it's almost like you think about like leaning in the wrong direction versus the right direction. So if I would respond to something like a word like fast, if I was given an earlier word, meaning like speed or quick, and I would respond slower to the word fast if I was given a prime that pulled in the opposite direction, like turtle or stuck. And psychologists have been using these to these reliable reaction time effects for years for different purposes, talking about like implicit bias and different ways that we work psychologically. But what I tried to do is I wanted to use them to test the consciousness causes collapse interpretation, because of the fact that you can measure the effects of something, the reaction time, without actually being conscious of it. I thought that it gave like a wedge to like get in there to measure, to be able to differentiate between the two.
I want to go back to the notion of superposition in quantum physics. I think we need to explain that as well. It's related to the quantum wave function.
Superposition is when things exist in multiple states simultaneously. So if you take the wave function, you can be thinking of it as a photon went on this side of the plate or that side, the top or the bottom. And when something's in superposition, what it literally means is it's not at the top or the bottom, the left or the right. It's not both at the top and the bottom, or neither. It's everything kind of put together. There's no specificity. So it's all the outcomes existing. That's when something's in a state of superposition. And what I was doing with the experiment is I thought, what if I could put these primes that affect reaction time? What if I could put the primes in a state of superposition? So I took the priming studies, and what they would do is they would show a stimulus on the TV screen for a very short amount of time that you couldn't see, and they would follow it with a different stimulus. And I set it up so I use numbers. So the primes would all be numbers, just single digit numbers, 1 to 10. And then the stimulus items, which is what the subjects had to respond to, were also 1-digit numbers. And what they had to determine is whether they were even numbers or odd numbers. So it was numbers 1 through 9, even and odd. And so sometimes they would see a 4 and they would hit even for 4. And if they would see a 5, they would hit odd for 5. And then we would measure with the computer down to the accuracy of 1 millisecond how long it took for the subjects to respond. But the primes the subjects saw before, we put into superposition. So they wouldn't collapse.
I presume in conventional psychology, the primes are going to be presented to your research subject in a random order. And that random order is usually determined by what's called a pseudo-random number generator, which is different than a quantum random number generator.
Yes. The pseudo-random number generator is made off of algorithms. So it's not, it appears random, but there's a different level. That the quantum one, if you're doing it based off of a Geiger counter or another means of making a quantum random number generator, it's based off of the fact that the superposition is random and how it collapses. And it's a different level of randomness because it's connected to, that reality that exists behind it. It's not the reality of the calculation.
In other words, in order to achieve superposition, the randomness needs to be quantum.
Absolutely. It can't be pseudo-random. It can't be from a mathematical algorithm that just runs a function over and over. It has to be based on what elementary particles are doing.
We've done a number of interviews on the New Thinking Aloud channel with a philosopher of quantum physics, Ruth Kastner, who bases her position on the interactionist interpretation of quantum physics developed by a physicist named John Cramer. And she maintains that, like the number 3 that you described earlier, the quantum wave function is real. It's actual, but it doesn't exist in time and space as we know it. It exists instead in this Platonic realm, but she would insist it's very real. So she has a book, I believe it's titled The Actuality of Possibility.
Well, I would agree with her on that. I do take that psiontic view, which means that the wave function is a real part of nature. The mathematics in between measurements, that function is the reality. There's no other reality that's underneath it. Physicists are debating that, now with, theory and arguments, but I'm definitely of that view.
From that perspective, one might say that reality, as we understand it theoretically, is actually just a big probability wave that we exist in probability foam, but it appears to us to be solid and three-dimensional with one dimension of time. Because of our consciousness, it takes that probability wave in which we're really embedded and turns it into something that we imagine to be solid and concrete.
Amen. That's exactly it. Well said. That's exactly what we're trying to say.
So you've devised this experiment now to establish scientifically that this is the case, not just philosophically.
Yes, that's what we're trying to do. That's what I'm trying to do with the subliminal priming study. And so what happened was we took the primes, but we based them, like you said, off of what was happening with off that quantum world. We based them off of the input from a Geiger counter. So those what prime was shown was based on what happened with this radioactive decay. And So what would have been inside the computer is all the different options. They would have been in superposition. The option that the prime could have been the number 1. The prime could have been the number 2, 3, 4, 5, 6, 7. They all had a certain percentage likelihood of occurring. And only when those primes were observed by consciousness would they select into one spot, being a 5 as opposed to a 6. But when the primes were hidden from consciousness, they didn't collapse until the later data collection, until I looked at them later on my computer. While the subjects were taking the test, those primes were in a state of superposition. So they were existing as a 1, 3, and a 4, and a 2, and all those other numbers as a jumble. So the hypothesis was this. Before the subjects took the test, I looked at half of the primes, and only half of the primes, which, according to the consciousness causes collapse interpretation, would have collapsed them into the specific state. So they wouldn't have been all the numbers. They would have been specifically 5, 4, 6, 9. And on the other half, I left them completely unobserved. So according to the consciousness causes collapse, because they weren't directly observed, they could still be in a state of superposition. And then I compared how those primes affected reaction time, how the observed primes that I already collapsed by explicitly looking at them compared to those primes that were in a state of superposition. And what I found was that the primes that were observed had a large effect on reaction time, meaning if I primed you with an even number, you were already leaning that way and you were more likely to answer faster. And if you were primed with an odd number, but the number that you had to respond to was an 8, let's say, you'd be pulled in the odd direction and you would have to kind of like correct. So it would take you longer to respond to the opposite way. And the numbers that I got were that the reaction time was about 2 to 2.5, up to 4 times in one study longer when the primes were observed as opposed to when they weren't observed.
Now, I would imagine that you could also simply compare the reaction times overall from without any observer, with the primes being developed through the quantum random process, as opposed to the database that must already exist regarding reaction times using a pseudo-random process.
Possibly, yes. That would be possible.
Hasn't been done yet, I gather.
I don't think so. Every experiment's a little bit different. I could follow one or reproduce one if I followed it. Psychologists aren't so much interested in how people respond to, this is why I'm thinking while I'm answering. Psychologists really don't care about responding to like an even number versus an odd number. I did that because normally when psychologists do it, they do words. So if they want to try to get at implicit bias, so they could like put the word like bad or good next to certain things, and based on how people respond to the other word that they're trying to get at, you can see unfiltered, how they feel about things. But that's what psychologists are interested in. So I don't know if there's a storage of numbers. I put the numbers in because you get larger effects, and it's more plain than what they were doing about feelings and biases and things like that.
As I have discussed with you earlier, I took a real fascination with your study to the point of seriously considering reproducing it myself, if possible, replicating your findings, because I think the significance from a philosophical perspective is just outstanding. And of course, in psychology, in recent decades, there's been a crisis of replicability. And so I began digging into it. And what I gathered is that what's called semantic priming, which I think is what you're describing, isn't considered as reliable these days as numeric priming, that the numeric priming experiments, such as the one you're conducting, survived the crisis of confidence in psychology in general, having to do with replicability. But semantic priming studies, although they were more interesting in psychology and studied more, are now being called into question.
True. The numeric is way more replicable. And when I started doing it, when I tried to put this together, the first thing I did was, I did it with the words. And I was just doing it with, my friends and family just to see if I can get that priming thing to work before I even started messing with anything quantum to hook it up. And I wasn't getting the reliable effects using words. But as soon as we switched over to numbers, when you use numbers, it's much more reliable because it's simpler and everyone's got a different psychology. And the other thing is with words is, can you read a word? Can everybody read the word if it's got 6, 7 letters in it? Even if it's got 4 letters in it, as easily as you could tell that a 1 is a 1 or a 2 is a 2 when it's happening in such a small bit of time. So for my purposes, that's why I use numbers.
Let's talk about your actual results.
There's 4 different experiments that were published in 3 different papers. The last paper had 2 experiments in them. And in every time that the experiment was run, the primes in the observed condition had a much higher effect than they did in the unobserved condition. So, and when we're talking about the effects, we're talking about everything is in milliseconds, which is 1 millisecond is 1,000th of a second. So in the first study we did, in the unobserved condition, the difference between the primes that were congruent with the stimulus versus the primes that were incongruent, they pulled in the other way, was 9 milliseconds. But when they were observed beforehand, the difference between the two was 37 milliseconds, which is 4 times higher. It's quite a bit higher. Ran them the experiment again. And the first time we had an average of 250 iterations in each group. So we had, in the observed condition, we had about 250 that were congruent with the prime compared to another 250 that were incongruent. And then in the unobserved condition, we had the same thing. We had about 250 that were congruent compared to another 250 that were incongruent. And that's what we're looking at, the difference between those two. So
the difference in reaction time.
Reaction time. And when it's observed, the reaction time is bigger. It makes a big difference if I look at the primes before, if they're going in the same way as the item versus the opposite way, like an odd and an even or an even and an odd.
Let me just also bring up the observation is made by you, the experimenter in these studies, not by the subject.
Correct. What I did is when I took the information from the Geiger counter, I looked at it on the computer screen for half of the primes and only half of the primes. And for the other half, it just went right in without me looking at it. So it was more automatic.
How long did you look at it for?
I looked at it by scrolling down. It was a simple thing. I didn't meditate on the numbers. I didn't stare at the number 4. I just looked and I read the numbers going down the stream.
So there might
ones
be
in the observed condition.
And how many numbers would there typically be at a time when you do the observation?
Well, in the first study, we did groups of 80. So 40 were observed and 40 were unobserved. So I would have observed 40. And in the other studies, I made the groups a little bit larger. I think it went up to 91. So between 40 and 50.
And you probably did that over a period of 10 or 20 seconds, I imagine.
Yeah, something like that. Just reading down the numbers, looking at them all.
And of course, your research subjects were, I presume, were not aware of what you had observed, or whether you had observed some numbers and not observed other numbers. They were unaware of that. And I also presume that the primes were then presented after you observed them in a randomized order.
How it worked was this. They would see 15 of them from the observed condition. Then the next 15 would be from the observed condition, then 15 in the unobserved, and it would keep switching like that.
I see. Alternate.
And then whether or not they were congruent with the stimulus was just kind of like random chance. Each particular one, depending on, whether we showed a 5 and a 4 or an 8 and a 2.
Because the stimulus numbers were also selected using, I'm assuming, a pseudo-random process.
You're right. The stimulus numbers were pseudo-random, just the random function in the computer program, but the primes were based on the output of the Geiger.
And your results?
Yes. So the difference is slower reaction times when it's congruent, longer reaction times when it's incongruent in the observed condition compared to the unobserved condition. So in the first study, difference of 37 milliseconds compared to 9 milliseconds. In the second study, the difference was 47 milliseconds compared to 17. So still the same, weight difference. And then in the third study, the ones that were observed by human beings, but not human beings, by me, 44 seconds. And the unobserved primes were, sorry, I said 44 milliseconds versus 21 milliseconds. And then in the last time we did it, the fourth study, it was 48 milliseconds for the observed condition versus 17 milliseconds for the unobserved condition. So it's about a 30 millisecond difference, 20 to 30 millisecond difference in every one. Some of these studies, I had subjects responding verbally where they would say odd, even. And then the response was recorded in a microphone. And then on the other ones, the second one and the fourth one, I had them hitting keys. I thought that maybe the saying them would result in a larger difference. That's why I did it again on study number 3. Study number 1 and number 3 had participants saying the response verbally. But then after I did it again on study 3, I think that it's all basically the same. And it's much easier to do by hitting buttons than speaking the words odd or even. And it's also easier to score because you don't have to listen to all of those recordings.
So your interpretation is that the observed condition where you had observed the prime numbers generated by a quantum mechanical process in advance caused the collapse of the wave function, and therefore the priming effect was stronger.
Yes. Or I would explain it very close. I would explain it a little bit differently. I would say that if physicalism were true and everything collapsed when it hit my Geiger counter, there should be absolutely no difference between if I looked at half the primes or not, because they would have all been collapsed way before anything happened, before I even readdressed my computer. Everything would have been collapsed if it occurred when the radioactive decay from my little piece of uranium ore interacted with the Geiger counter. There should be no difference. Should be no difference at all if physicalism were true. And then what I think that we did is when I looked at the primes, I collapsed them. So those worked the way that they were supposed to work, and they did. And then in the ones that I didn't look at, some of them inadvertently must have collapsed because it's hard to maintain that level of isolation. But the fact that the observed ones work better, I think we're comparing groups where all of them collapsed when I observed them to ones where a group where some of them didn't collapse. That's the only way that I can explain why observing would help the effect, and my not observing actually would diminish the effect. It's like we put like a block on the effect because of the fact that they weren't observed. They didn't work as well because I don't think that they were all in specific states. And if you had a prime in a state of superposition that's simultaneously like a 6 and a 3 and a 5 and an 8, it's not going to pull in one direction or the other, as opposed to something that's definitely in a spot. This is definitely a 3, and it's definitely congruent with a 9 if I'm doing an odd or even test. So that's how I would think of it.
In other words, even though you didn't observe half of the primes, and presumably they weren't observed by anybody at all because even the subject never was consciously aware of them, the wave function somehow collapsed by itself, or there would have been no effect.
Well, I would say this. When we looked at, in order to do the statistics, we have to do, to see if it's what those primes were. So when we're actually doing the data analysis, at a later date, then I'm looking at them all. Then they're coming into contact with the data, the consciousness of the person who's doing the data analysis. And they have to be, that prime has to be a 5 as opposed to a 6. It can't exist as both a 5 and a 6 because we're looking at it then. So what we're basically doing, you're right, we're observing one before the task, and then the other one gets observed in the later data analysis. Because otherwise, we wouldn't be able to pair up to find out if it's congruent or not, because at some point they collapse when I look at them later.
So when you look at them later, I gather what you're suggesting is that the collapse somehow works in a retrograde fashion backwards in time.
Absolutely. I think that's exactly how it would have to work. There's no other way to explain it. It would have to be that way.
It would be analogous to a whole fascinating line of research in parapsychology known as retro PK.
Yes. There's a lot going on with parapsychology, with that and with the presentient effect. And I think that we're uncomfortable with science in general. Mainstream science is uncomfortable with like retroactive effects. But I think there's a lot of possibility to things that need to be explored, using retroactivity. And I think that once there's once there's an explanation is more accepted, then all of a sudden we'd be able to deal with these things more. But as far as idealism, that idea of like retrocausality, it goes back a long way. It goes back, it even predates quantum mechanics. That idea that, the universe depended on like the first eye that opened, to collapse things, to start the process going through. I think that's Schopenhauer, actually. I think that's a couple hundred years old, that idea.
We need to point out that conventionally speaking, physicists by and large assume that once the output of a quantum random process has been recorded by an instrument like magnetic tape, for example, or some sort of magnetic storage, at that point, the wave function has collapsed.
Yes. That is the mainstream view. Or in non-collapse theories, like Everett's many worlds, that's when the universe has split. But regardless, from our position, it's over. It touches the machine, it's over. There's no more variability. It's the superposition has ended. Von Neumann said it goes a little bit further. You have to wait until it interacts with consciousness. That's the dividing line.
So from your perspective, you're in agreement with von Neumann on this point. From your perspective, if we had the output of a quantum mechanical random number generator, and we take that output and put it onto a magnetic storage, and then go from magnetic storage to a printer and print the output on a printer, but nobody has seen the printed output on a printer, that output would still be in superposition until somebody views it.
Yes. I think that we increase the danger of decoherence happening how many times we copy that. Like if you were going to say, well, then we took that printer and we put it in a hot air balloon, we dropped it off to another scanner somewhere else, and then this happened and this happened. If we did like 500 steps, well, every time you do a step, there's danger of collapse because, consciousness is kind of around. But doing it on a small level, yeah, absolutely. And even theoretically, I suppose if you did it 1,000 times, but you were careful enough from copying it to hide it from consciousness, theoretically, yes. Consciousness is what I think would be causing the collapse.
Of course, it brings us down to the definition of consciousness itself. As I recall, for example, you conducted an experiment with your cat in which you had your cat view the primes. And as I recall, that didn't seem to work so well. You don't believe the cat was able to collapse the wave function by viewing the primes.
That was shocking. Let me, go back and talk about this because this is kind of interesting too. I can't if anybody has a cat, you can't make a cat view anything because a cat's going to look where a cat's going to look. But what I did is I had the Geiger counter, which makes a certain sound and this is just a plain person's reasoning. It's loud enough for a cat or any mammal to hear if it's inside the same room. I mean, it's clicking or it's not clicking, and it's obvious. So for a section of the data I took for the third and the fourth studies, I did them where nobody was looking. I did them where I was looking, but I let the cat listen to the clicks of the Geiger counter, and I compared that to when nobody was looking at all, and then to when I was looking at half of the primes. And you're right, the cat did not seem to collapse the primes. It was much lower than what I got when I was looking at the primes, and it was like nobody was looking at them. Actually, a little bit lower than if nobody was looking at them. I don't know what that means. There's two explanations I can think of. One is the cat was somehow able to totally ignore the sound after it habituated to it for 30 seconds. I don't know. There's other things I could do to make it more obvious, I could hook up the Geiger counter to lights and sounds that might flash in the whole room to make it more where the cat couldn't ignore it. I don't know. I didn't do that yet. That maintains a possibility that the stimulus wasn't enough, because I can train myself. I'm going to look at these numbers, but the cat has to hear it. But then I would think that collapse would be really sensitive, and it should have worked. I was surprised that it didn't. The other thing is that the collapse of the wave function might be something that's tied specifically to human consciousness that doesn't extend universally. I don't know. I don't know what the difference is between those, because I just assumed that the cat listening to it would collapse it just as much as me looking at it. I 100% assumed that, and it was a surprise. It was a surprise outcome, but it would need to be fleshed out with the research design where the stimulus was made bigger for the cat, where it would be unreasonable to assume that the cat didn't experience it. And I guess there's enough doubt, because I don't know how a cat's attention system necessarily works.
Now, there is a famous limerick, I don't know if you know it, about God and the quad, but the idea is, I think it's based on the philosophy of Bishop Berkeley, that if there's nobody around in the quad, well, then the quad being an area on a college campus, then it doesn't exist at all. And then the second verse of the limerick is God saying, well, I'm always around in the quad, and I'm conscious of everything. Therefore, that's why everything exists, is the idea of the divine omniscience.
What a good point to bring up. Yes, Berkeley, that's exactly what he thought. 300 years ago, well, it's almost like Berkeley said, to be is to be perceived. Or is what we might say today, like maybe using more of like a video game words, reality is rendered as it's perceived. Like when you walk through like a video game, this room doesn't exist until I'm in it, and then now it exists. But for Berkeley, his metaphysics relies on his theism, on his faith that there was a God who's watching everything all the time. So from Berkeley's perspective, even though we're both idealists, he would be like, Rick, none of this makes sense. God's collapsing everything because God sees what's happening on this Geiger counter the second it happens. Nothing's waiting for you. So that's how Berkeley would see it differently.
Your experiment, however, if it could be replicated more widely, would demonstrate that Berkeley was wrong on that point, that human consciousness has a specific role.
I'm tight with Berkeley in the way I think about that. So that's an interesting point, because he's doing something different. He's saying that it exists because I see it, because people see it. And if people aren't observing and perceiving, then there's always God preserving, like as a backup. But that's not so. If there was so what Berkeley's saying, you're right. If there was an omnipotent God, he would be collapsing everything. He would agree with the physicalist that everything collapses upon the interaction with the Geiger counter or the photographic plate. Yeah, I got to think about that one a little bit. But I see what you're saying. That's troubling, because I want to support Berkeley. But yeah, that's interesting.
Well, the real key, I suppose, is that there needs to be more than the 3 or 4 experiments that you've done so far. We're dealing with such a profound question that addresses the relationship of consciousness to the physical world and where they might actually interact, which is a big bugaboo, particularly for dualists who suggest that consciousness and the physical world are two separate metaphysical properties. Then the dualist has to explain how they interact with each other. I believe Descartes said it all happens in the pineal gland of the brain, but most people wouldn't accept that today. It might more likely be the collapse of the wave function. So it's a very crucial experiment, potentially, that you've come up with. But in order for it to be accepted in science, it would probably need to be replicated 100 times.
Absolutely. And I think that it is super important. Super important. And von Neumann's hypothesis is so there's not much that it wouldn't touch if it was true. It would change psychology. It would change physics. It would change philosophy. It would change so much. And I think this is a worthy avenue to pursue. This subliminal priming, methodology, or other things with experimental psychology that could possibly also be used to test von Neumann's hypothesis, because it's not something that. So the discipline is quantum mechanics is inside physics, but if physics, even though they're the masters of it, and I'm certainly not. I'm a psychologist. I'm a philosopher. I stay in my area. But if idealism were true, then in order to get at the bottom of physical reality, we would need something from a non-physical science like philosophy or psychology to be in there. So I don't think that this is an physics experiment that I did. I think it's a psychology experiment that has the topic of physics, because I'm not doing it's the Geiger counter is a very simple thing that I bought and plugged into my computer. I'm not doing a physical experiment. I'm doing a psychology experiment that's tied. So it's a very strange place. And I don't think that physicists are going to be like, well, I'm going to test this. I'm going to go get some subliminal priming and we're going to do this psychology stuff. So it's going to take, I think, people who are familiar and comfortable with idealism and psychological methods to, flush this out.
And I have to presume that within academic psychology, there's almost zero interest in the question of whether or not consciousness collapses the wave function.
Unfortunately, I think you're 100% right on that. If I was a professor, if I would have went a different route, I'm a clinician, so I make my money by delivering psychological services. I have a PhD in psychology, but I'm I work with children and people with disabilities. But if I was a professor and I was worried about tenure and publishing, I could see, I'm not going to do this right now. I need to do something, about autism or something that's just more, accepted. But this is what I want to do. And I'm kind of lucky, because if I'm not accepted in that world or nobody pays any mind, it doesn't hurt me. So I'm kind of have that privilege of not needing that, because I'm okay. I do other things.
Well, we need to find more people like you. My hope is that amongst our large viewing audience, there will be other people who have the background, experience, and interest in replicating your study, because it seems to me to be a fulcrum, a real turning point if the study can be more widely replicated.
Yeah, I hope so too. I really hope that it's that people try these methods and work on it, because I think that it can be.
And I'm sure you would be willing to provide some assistance if anyone out there is willing to give it a try.
So, absolutely. I have a website where I have all the computer code for if you wanted to use the Geiger counter, how that interface works. I have all the code for that. I have all the code for the psychology experiment, the priming experiment, using Inquisit software. And that's all free to cut and paste on my website, testingtheccc.com. So that's all right there. If anybody wants to take it, I try to be as clear as possible, but if you don't understand some of my notes on it, my email is on the site too, and I'll be happy to answer any questions.
Well, Richard, I'm delighted to be able to share your work with the New Thinking Aloud audience. I think if your findings could be more widely confirmed, it would have revolutionary importance. So I hope some of our viewers will take advantage of this opportunity. Who knows? It might lead to a Nobel Prize for somebody, for you perhaps.
Oh, I don't know. But I had a lot of fun. I don't know about that, but I had a lot of fun talking with you, and privileged to be on today.
Thank you so much, Richard. And for those of you watching or listening, thank you for being with us, because you are the reason that we are here.
Book 4 in the New Thinking Aloud dialogue series is Charles T. Tart, 70 Years of Exploring Consciousness and Parapsychology, now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.